Okay, so here we go, our 20.1b notes on sampling methods and results. I'd like you to point your attention here to 20.1b assignment is in your textbook, page 779, numbers 1 through 12. If you would prefer to do the electronic textbook, I will put lesson 20.1 in the locker for this class. Please note it will not be page number 779, but you will do that assignment, the homework at the end of that lesson, numbers 1 through 12. So, some more words. We got to talk about sampling methods. Now, sampling methods are important because they can create a very biased or unbiased survey. So, one type of sampling is called convenience sampling, and convenience sampling is when you are sampling individuals who are easy or convenient. That sounds kind of strange, but if I needed to collect some data and I just asked the 15 people that were closest to me at that moment, that would be a convenient sampling, because that wouldn't necessarily be 15 random people. It would just be the 15 people that were closest to me at the time that I needed the data. A self-selected sample is when individuals volunteer to participate. So for example, if I had, let's say I did a Google Doc, or a Google form I should say, and I asked people to please go onto the Google form and fill out my survey. Those individuals that choose to go on to that Google Doc to fill out the survey are volunteering to participate. So it is a self-selected sample. Sometimes you will see commercials or billboards for medicines that people are wanting to test medicines to see if they're effective or not. And they'll say, if you struggle with depression, call such and such, and we'd love to get you in on a study, and they'll provide you free medication or something because they want to see if the medicine works or not. Well, if you are choosing to participate in that survey, then you are participating in a self-selected sample. There's also a systematic sample. In a systematic sample, individuals in the population are chosen according to a rule, such as putting them in a list, putting them into a list, and every third member is chosen, or every 5th member, or every 10th member. Okay, sorry about that. I just had a little interruption. Let's see. So systematic sample is putting them into a list, and every 3rd person is chosen, or every 5th person, or every 10th person is chosen. Some kind of a system to the way that you are choosing people. If you choose every other person, that would be a systematic way of selecting a sample. A simple random sample, sometimes we abbreviate it SRS, is a simple random sample, where every member of the population is equally, I can't spell sometimes, equally likely to be chosen. That is your ultimate goal, is to have a sample where each member of your population is equally likely to be chosen. Now, we have a cluster random sample. This is a way of getting a quote-unquote random sample. What we would do is we would take the entire population and we would divide it into groups. Groups or clusters, whatever you wanted to call it, and some of these clusters or groups are randomly selected. Every cluster is equally likely to be selected. For example, the entire population is divided into, let's say I was doing so, sorry, I had another interruption there. So a cluster random sample, the way I think about this is, let's say all juniors happen to be separated into or divided into clusters based on their English class, or let's say their English teacher. So all juniors are already into these clusters based on what English teacher they have. They could either be a Wheaston cluster, or I don't know who the other English teachers are, or a Solano cluster. I don't know if she teaches junior, but you get what I'm saying. Each teacher would be considered a cluster, all of their students. And then some of these clusters are randomly selected. So maybe we chose to sample Wheaston's group and someone else's group. Every cluster would be equally likely to be selected. So if we chose Wheaston's group, we would survey every single student in Wheaston's class. All subjects in the selected cluster are included in the sample. And that's important to note because that often gets confused with stratified random sample. A stratified random sample is the entire population is divided into groups again. This time they're called stratum. And random samples are selected from every stratum. Every subject within a stratum has equally likely chance of being selected. So let me use my schedule as an example. I have 5 periods of classes, periods 1, 2, 4, 5, and 6. Let's just use my IM3 classes, periods 4, 5, and 6. Now, they are already, because you are in either period 4, period 5, or period 6, you are already divided into groups based on that. If I was doing a cluster sample, I would randomly pick one period, such as 4th period, and I would ask all the students in that class to take the survey. If I was doing a stratified random sample, I would have my classes still, periods 4, 5, and 6, but rather than choosing period 4 and asking everyone in there, I would maybe choose 5 students randomly from period 4, 5 students from period 5, and another 5 students from period 6, so that it was randomly from each group that I had. That's the difference between those two. A representative sample is a sample which gives a good estimate of the corresponding parameter of the whole population. So that means it is usually random. I gave some examples yesterday about civil rights, when you had an African American man who was in court for some reason, and if he had an entirely white jury, that would not be a representative sample of the population, and therefore he got a biased result based on what society wanted the result to be at that time. A representative sample, they try to do a representative sample, I believe it's for homecoming court, or is it homecoming floats? I don't know. But where they get a representative from each club on campus and each extracurricular activity and every sport. And so that way each person has input and each person brings their own biases based on whatever they're involved in, but put them all together and you can extrapolate the data to represent the entire population. A biased sample, on the other hand, is a sample which can produce statistics about the population parameters, which can produce statistics that lead to inaccurate conclusions about the population parameters. So if I asked you guys all who your favorite math teacher was, biased sample, you're already in my class, you are more likely to say me, simply because I am the most fresh math teacher in your mind, because I'm the only one you've got. You'd have to think back to other ones, so if you just want to answer quick, you'd answer me and be done. Okay, so suppose that we have a population of 500 IM3 students and want to form a random sample to determine if starting the review for the final exam 3 weeks early will improve their grade on the final exam. Describe how you would randomly select the sample group using the following techniques. If I wanted a simple random sample, remember that SRS thing from above, I could use a computer to randomly select some of the student ID numbers, or I could mix up all the names in a big bin and draw names. Anytime you hear something of putting all the names in a hat and drawing names out of a hat, that would be simple random. Every single number has an equally likely chance of being drawn. That makes it a simple random sample. A cluster sample. I would get a list of all the classes and their students, and then I would randomly choose several classes and use all the students in those classes. So again, with my classes, if I looked at my periods 4, 5, and 6, I would maybe give period 4 their final exam review 3 weeks early, and then compare their results with my other classes that did not get it 3 weeks early. A stratified sample, which would mean I would get lists of all the students, and then I would select the same number of students from each teacher or from each period if I was doing that. So if my 4th, 5th, and 6th, maybe I chose 5 students from period 4, 5 from period 5, and 5 from period 6, and gave those students the final exam review 3 weeks early, and then compared them to how everybody else did on the final exam. That would be a stratified example. All right, so convenient samples, self-selected samples, and systematic samples are not quite random. Think about why they might be biased. So if I have a convenient sample where I give out the review early to the people at the front of each row, why might that be biased? Well, it might be biased because front row students may sit in the front row for a reason. Perhaps they are already more engaged in the class. Perhaps they are stronger students already, and they like to be up in the middle of everything and want to be focused on what's going on. So giving them to the front at each row, the front person in each row, could be biased based on why the students sitting in the front row are sitting there. Or it could be low students maybe that need to be away from distractions. That could be biased as well. It can be biased in a negative way as well. Self-selected, take volunteers who want to start early. So if I ask for volunteers who wants to start reviewing for the final exam 3 weeks early, and if you volunteered and I gave you your review early, why would that be biased? Well, it could be biased because they may already be the students who are super conscientious about their grades anyways. If they are the proactive ones, the ones that don't necessarily procrastinate as much as the others, then they would be ones that would be more likely to utilize the study guide regardless of when they got it anyways. So I'm going to say, let's see, they may already be the students who really care about their grades. And finally, a systematic one. Every 5th student on the roll gets the review early. This is pretty close to random if I can't do a completely simple random sample. This is the closest I can pretty much get. The only reason this would be biased if there's some problem with the original order. So what's the reason for the order? So for example, did I list the students from the highest grade down to the lowest grade, or vice versa? If I changed the order to be some specific reason and then I did systematic, then there's some bias in the way that I did that. If I don't change the order and I just leave it randomly alphabetically, That is the closest to a strictly simple random sample that I could get. So it is a good method to be used if you can. All right, back of the page. Types of results, the mean. When you collect numerical or quantitative data, it's usually the best way to analyze the results is to calculate the mean of the data. What do? It is the sum of all the numbers divided by the number, this sounds weird, the number of numbers. In other words, it's the average. Okay? Often standard deviation will also be used. We will learn about that later. When you count, proportion can also be a type of results. When you collect categorical data or qualitative data, these terms are used interchangeably, by the way. The results are reported as proportions, percents, fractions, or decimals, saying how many had each result. So, for example, we could say 25% of the population say that their favorite color is green. That's a proportion or a percent that would be used to represent categorical or qualitative data. The reason why you would use a proportion is because it makes no sense to calculate a mean. Even if your results happen to be numerals. Remember yesterday we did this whole list of numerical data versus categorical data. Over here, our mean has no meaningful results, so there's no reason to calculate a mean. Often only two results are possible. So a lot of times they're yes or no questions. 30% of the population say they like chocolate ice cream. Well, what were their two options? Do you like chocolate ice cream? Yes or no? Those were your options. Predictions can be made by multiplying the mean or the proportion by the population numbers. And predictions also are often referred to as expected values. Okay, so here's an example. A survey was taken of 10 students out of the 3,000 students in school. Students were asked whether they like ice cream or not, and then if so, do they prefer chocolate or vanilla ice cream, and how many times per week do they eat ice cream? The results of the 8 who like ice cream are in the table. So here's the flavor, whether they like chocolate for C or V for vanilla, and how many times per week they have ice cream. Which data is categorical? Well, that would be the flavor. Also, technically, whether they like ice cream, yes or no, is also categorical. The numerical data would be the times per week. Numbers, words. Is it discrete or continuous? Well, this one would be discrete. The reason is they're not having it 2.5 times a week. They're either having it or they're not. So it's either going to be a 1, a 2, a 3, a 4, a 5, a 6, a 7, or they're not going to have it at all. So you're not going to have a 2.5 times per week. Do you think this was a representative survey? No. I could not take the data from 8 people and honestly say that that represents 3,000 students in the student body. That is not a representative of the entire population. Okay? All right. What proportion of the students surveyed like ice cream? Well, they surveyed 10 students. 8 out of the 10 students responded that they liked ice cream. So my proportion would be 8 out of 10. If we were talking decimals, that would be 0.8. If we were talking percentages, that would be 80% of the students surveyed like ice cream. Predict how many students in the school like ice cream. Well, if I use that information, I would take 0.8 and multiply it by the school's population, which is 3,000, and I get 2,400 students in the school like ice cream. So if I base it off these 8 people, even though this wasn't a representative survey, if I base it off there that 8 out of 10 students like ice cream, then that would mean that 2,400 out of 3,000 students like ice cream. That means there's 600 people that don't like ice cream. I don't know if that's very realistic personally, but whatever. Out of those who like ice cream, so out of the 8 who like ice cream, what proportion preferred chocolate? Well, 1, 2, 3, 4, 5 out of the 8 preferred chocolate. As a decimal, that would be 0.625, or as a percent, that would be 62.5% of the students who like ice cream prefer chocolate. Now, I don't want to say 62.5% of the students, because it's not 62.5% of all the students. It's only 62.5% of the 8 who liked ice cream to begin with. Predict how many students in the school prefer chocolate. Well, let's see. 5/8, oops, sorry, I'm writing that wrong. 5/8 or the 0.625 of the students in the school who like ice cream. So not all of them, but if I'm extrapolating and saying that 2,400 likes ice cream, then 62.5% of that says that 1,500 students in the school prefer chocolate over vanilla. Excuse me. Among those who preferred chocolate, so that means out of this 1,500, what proportion ate ice cream? Sorry, not out of the 1,500. Let's go back up here. Out of the 5, what proportion ate ice cream more than once a week? Well, this guy did. That guy did not eat more than once. This guy did, and that guy did not. So that means 3 out of the 5 chocolate lovers ate ice cream more than once per week. That is 0.6 or 60% of the chocolate lovers ate ice cream more than once a week. Of those who like ice cream, that is my 8 people. What is the mean number of times per week that they eat the ice cream? So, of these people, my 8 people here, I need to find the mean number of times per week. So that would be 2 plus 1 plus 3 plus 3 plus 2 plus 2 plus 1 plus 0, all divided by 8 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8. That gives me 14 over 8, which is 7/4, about 1.75 times a week. And now we said this was discrete, so 1.75 times doesn't really make sense. We would round that off to probably 2 times per week. Now, predict the total of times per eat ice cream is eaten by those who like ice cream. So let's talk about the whole school now. Again, 2,400 people in the whole school. So let's do the 1.75 times per week times the 2,400, which means that I get a result of 4,200. That means that of the students who like ice cream is eaten 4,200 times per week by students. That's a lot of ice cream. If I was selling all this ice cream at $2 per serving, what would my income be? Well, $2 times 4,200 servings means my income would be $8,400 in 1 week. That's not too shabby. So those are just some calculations you can do with your data, some statistics you could come up with. Now the statistics would be the ones that are dealing with the survey. So I have a statistic right there. And as soon as I go to the whole population, there's my parameters that we're talking about. So again, your homework is on the front here. I will put lesson 20.1 in the locker if you would like to look on that. Ignore the page number, just do numbers 1 through 12 in the homework section. If you're going to use your actual textbook, you're going to go to page 779 and do numbers 1 through 12.